text me. I get lonely. It's 1 a.m. and no student has texted me. It makes me sad. Alrighty, so functions. What is a function? It's a collection of statements to perform a task. I would call it a named body of code or a named collection of statements, right? You're going to calculate pi. You could stick that in a function and you could call it calculate pi, and every time you needed the value of pi, you can call calculate pi, because it is a mathematical formula. It's just one that never resolves. It's an infinite number. So modular programming is breaking a program up into smaller, manageable functions. So like you're creating a report. You might make a module that opens the database. You might make another module, and modules can be a synonym for function, that reads in all the data. And you might write another module that processes the data to create tallies and to write them into an array. And then you might write one more module that creates a pretty report based on those tallies. So, motivation for modular programs improves maintainability and simplifies the process of writing programs. Those are actually fairly true. If you have 10,000 lines of code, just all starting at the top of main and going all the way down to the bottom, and then somebody asks you to maintain it, I'd quit and I'd find another job. If it's nicely broken up into modules and files and stuff like that, it's far easier to find the code that you need to fix. It allows teams of people to work on the project. Somebody could be working on one file or one module, and somebody else could be working on another. And if, as you're thinking about the program, you can mentally divvy out what the functions, the modules are going to be, and you can get that, write them down on a piece of paper and share them with other people, then it makes it a lot easier. So that if you can visualize it, you can code it more easily. So this is terrible. 8 million statements in a row. If we can block them off into several different functions, and then our main can call those blocks, lots better. Defining and calling functions. The function definition, or the body of statements that make up the function. Something's nagging at me about that because we've seen prototypes. But let's just run with our definition for now. Function definition are the statements that make up the function. All the code that calculates pi, all the code that tallies the database. The function call is when the function is executed. We've been seeing those a lot, right? So you have main, and then you write a function. Foo's got some data that it calculates, and then returns that value. This is the function definition. That's the body of the function. By their definition, the header of the function is considered part of the definition, which I'm glad to see. So this is the function header. That's the function body. The rest of this is the body. So the function definition includes all of this stuff: the return type, the name, and the parameter list, and the body. So the return type of this function is int. That's what it's supposed to return. So if we're going to call that function, we're going to store its result in an int. Alt x is equal to foo. Int x is equal to foo. I don't know what I said there. It sounded weird. Int x is equal to foo. So we have a return type, we have a function name, and we have a parameter list. This one didn't take any parameters. We could write a function that takes parameters. Something that M-U-L-T, that multiplies two numbers and returns the result. Int mult. We're going to multiply x by y, so int x, comma int y. We're going to calculate our result. Int r equals x times y. And it's going to return the result. This is the module name. This is the function name. That's the function return type. It's going to return an int. These are the parameter list. So it needs two parameters passed into it. The stuff we pass in are called arguments. So down here, when we invoke it, we call it. Call and invoke are the same terms. Invoke just sounds fancier. trying to impress somebody, say invoke. Alrighty, and then mult, that's the module name, the function name. I'm sorry, I've been teaching fundamentals earlier, and they call everything in there, every function a module. So I'm going to keep using the term module accidentally. Everything is a function here until we start talking about methods. And we're going to pass in 2 arguments. The 2 and the 3 are the arguments that fill x and y. So even if you haven't been taking notes, this is a good note to put into your CPP file. You may copy and paste it. Each parameter in the function header needs an argument. Now there are exceptions. You can give default values to parameter variables, in which case you don't have to provide an argument. So I'll put unless you give default values. What does that look like? Here's what a function with default values looks like. Let's write a function that, well, not DEF, that's Python. Let's write a function that adds 2 numbers. int add, and yeah, we could pop open Visual Studio and y'all could be following along, but let's just do it like this. And then we're going to return x plus y. So when main is going to call it, and it's going to be int z is equal to add, 1, 2. I want to add 1, 2. So I'm calling add, I'm invoking add, it comes up here, the 1 fills in that parameter variable, the 2 argument fills in that parameter variable, it adds the 2 together, returns the result, which gets stored in z. But I could provide default values. I could say that by default, x is equal to 0 and y is equal to 0. So I could do this. Now I don't know why. It doesn't make sense for this function. So I could call it again like that. And when I do, okay, that's just totally silly. So I'm going to give different default values, like 2 and 3. Now when we call add, we didn't provide any arguments, so x is equal to 2. So it's going to return 2. And we did not provide this argument, so y is equal to 3. So it's going to return 2 plus 3. Now for math, it does not make any sense to provide default values, most likely. But that's how the equal 2 and the equal 3 are default values for the parameter variables, or we can just say for the parameters. If you do not provide arguments, the default values, if any have been specified, the default values, I don't know why I'm trying to put this all in a comment, if specified, are used by the function.
That's int y. Int y.
Yeah. Why is there a seg any? Yeah. Thank you. The equal 2 and the equal 3 are default values for the parameters x and y respectively. Is that the term? Some English major tell me when you want to mention 2 things in a row.
That's correct, yeah.
Alrighty. I had a brain glitch. Okay. So this line without the body is called the function header. So in this example, this is the function header. I think I've already said that, and the rest of it's the body. From here down is the body. A prototype is a header without a body. Often prototypes are placed either at the top of the file, underneath your includes, or in a separate header file. The function return type, if you're not returning anything, you call it void. Now when you're doing math, you're probably going to want to return something. If it's a print function, you don't need to return anything, right? The calling program, the client code, so to speak, the main method, the main function, what does it need to know about this? It doesn't need to know anything. So we declare it as void so that when in main, when we want to call it, we just do print heading like that. And we don't store its result in a variable because it's been declared as void. It's not going to return anything. Why don't we go ahead and switch to Visual Studio? Are we on X?
Yes.
Alrighty. New project. We installed Windows 10 on this, but I think the machine is still like purchased in 2009. Not to complain, I'm glad to have computers. Alright, add new item, lecture X. Yeah. Yeah, you've been doing without it, so you know what that's like. Lecture X. Paste my boilerplate. Alright, let's do those functions that we were talking about. Let's do the add one, but without the default parameters, and then a print function. So, write a function called add with a return type of double that accepts two double parameters x and y. That's just the header specification. And there's a syntax for declaring that more succinctly, far more succinctly, but for now that's the English way. And then the body will add x and y and return the result. That's kind of like, you know, what you might see on a quiz or something like that. So, what did I say the return type was? Double. What did I say the name of the function was? Add. And it accepts two parameters. Now, wouldn't it be nice if we could do double x comma y? Can't. Double x comma double y. We could just do return x plus y. That would meet the requirements. I recommend usually calculating the result and then returning it in two different steps. Why? So that if you needed to debug it, you could set a breakpoint on that line and stop it. Find out what the value is before you return it. So double R for result equals x plus y, return R. Not showing an error here. I don't understand why. Expected a semicolon. Because I put this inside main. Alright, fire your professor and hire a new one, because that was pretty dumb. Alright, we're going to have to take all of this stuff and cut it and paste it after main. So everything from the hello world, which we don't even need, it's just part of my boilerplate. Take all the comments, take the entire function, cut it, paste it above main. Now let's add two numbers together and get the results. Double sum equals add 10 to comma 20. And we could print the sum out if we wanted to, right? So for you fundamentals folk, that's what's known as a fruitful function. Fruitful because it returns something. Does that mean the other ones are fruitless? I don't know. They're actually called void functions. So we're going to write another function. I've never used that joke before. I'm going to have to keep that one. Void print number, parentheses, string title, comma, double value. Just making something that'll print the number with a title in front of it. And I didn't even tell you to describe it. Or I didn't describe it. I could, but I'm going to write it instead. You know, it would say something like, write a function named print number, return type void, or just return void, that accepts a string title and a double value and prints them. Displays them with CI. That'd be enough. So we know the name of the function. Print number is the name. We know its return type, void, meaning it doesn't return anything. We don't even have to have a return statement. You do if it has a return type there. Accepts a string, title, and a double value and displays them. All right, let's do that. Cout, arrow, arrow, title, arrow, arrow, quote, space, quote, arrow, arrow, value, arrow, arrow, ENDL. And we don't need to return anything. We're just going to trust that it actually printed to the screen. There's really no way for it to fail unless there's a syntax error, and it's not going to run if there is a syntax error. The common thing to do is to make it return an integer code where 0 means success and a non-zero number is a error code. That's kind of old school. All right, so down here, now that we have the sum, let's print it out. Print number, parentheses, quote, this is going to be the title. The sum is, end quote, and let's pass in our variable, sum, in parentheses, semicolon. And the sum is 30. Good enough, right? And I've said it a couple times already, so I don't need to write it down. This is the header. Everything inside the curly braces is the body. If you need to define a prototype for it, that's just the header ended with a semicolon. You need that if the function is being called before it is being defined. So let's make up another function, like multiply. Double mult for multiplication. No, double product equals mult 10, 20 in parentheses. It's probably time for me to slow down and make sure that everybody's caught up. But I'm going to write a function, but it's not going to work because it's not going to be defined in the right place. So we're going to have to add a prototype. Let's write a function that'll work. We know what its return type is. How do we know what its return type is? Because it's being stored in a variable that's declared as double. So its return type is double. Its name, we can see it right there, underlined, MULT. We're passing in two values. These could be integers. Why don't we declare them as double to be more flexible? We might want to multiply 3.2 by 5.8. Double x comma double y. There's nothing magical about those variable names. You can call them Fred and Barney or Tony and Peter or whatever. And we're going to declare a resulting variable, double r equals x times y, and return r. Now in Java, that would be enough to get it going, because Java does not care about the order in which things are declared. This language does. So when I try to run it, it's going to display an error message, and it's going to say mult identifier not found. Well, it's right there. It's bigger than life. It's right in front of me. It's not declared in the right place, though. Just like you have to declare a variable before you can add something to it, you have to declare your function before you can call it. Easy would be to copy and paste, cut and paste that function. But instead we're going to use a prototype. We're going to scroll up to the top of the code and declare a multifunction prototype, which tells the compiler what its return type is and what its name is and what the parameters are. So if I correctly recall, its return type was double, its name was mult, and it took two parameters, double comma double. Now I like actually putting the variable names in this part of my prototype. And then after the close parentheses, put a semicolon. I think that variable names are useful information. So when I write my prototypes, I would usually put the actual variable names, X and Y, because there's no reason not to. But it's not strictly necessary because we're just telling the compiler, oh, you better be ready to accept two arguments that need to be compatible with doubles, and you better know that it's going to return one. And that way, when main calls it down here, it knows everything it needs to, right? It knows what pieces of data type these need to be and what the data type is that's going to be stored in the word product, in the variable product. So like I said, since I like having variable names in there, I'm going to make it exactly match. And what I usually do is I just copy the function header and paste it and add a semicolon rather than type it out. All right, I'm going to make sure it all hangs together by compiling it, and then I'm going to wander around because I'm pretty sure I lost at least four people because I just kept going too fast. Alrighty. Now we didn't print out the other one. If you want to print out the product, just make another call to the print function. Just go down to main and put out a second print statement. So when you call a function, you use its name, you follow it with parentheses, and if it has parameters, you fill them in with arguments, things between the parentheses. And it jumps into the body of the function. After the function terminates, I would say returns, execution resumes at the calling point. So when mult is invoked from inside main, right, it jumps down here into it, it runs those two lines, and then it returns. And you can even see that happening if you set what's known as a breakpoint. I'm going to click on this margin here. I'm going to start the debugger up, debug, start debugging. Actually, I could have just pressed the green, and that does it as well. It's going to run to that point, and then I have to figure out which of these little obscure symbols. And I want the one that says step over because I want to get to this statement. So I need step over. All right, it did it. It printed it out. If I went back to my window, I'd see that it was executed. Now I want to see what mult 10,20 is doing in its guts. So instead of step over, I need step into. Now I'm inside it. So I'm going to step over so that I get to that double line. I'm going to step over again. Now I can move my cursor over and it'll tell me what R is equal to. And since X is equal to 10 and Y is equal to 20, then R is equal to 200. I should spend like 2 weeks just on using the debugger. It's actually seriously useful. And then it's going to return, so I'm going to step over again. Now it hasn't actually returned, but it's set it up. You can see the cursor sitting here at the closed brace, implying that the next time I click the button, it's going to jump back to where it was, which is right here. It is now done with that, but it has not stored the value in product yet. So if you hover your cursor over product, you see that it's got that big old long garbage value. But if I do step over again, it's going to go to the next line, and now product has our answer that was returned. We see product 2000 or 200. And now it's sitting there waiting to run the system pause, but it hasn't yet. So if I do a step over again, and then I step over here, it says press any key to continue. And so I'm going to stop my debugging by pressing the little red square. All right, that's using the interactive debugger by setting a breakpoint. A breakpoint just means break the program at this point, stop the program so that we can start looking around. And when you have logic errors, that's what you do. Prototypes. We've talked a lot about prototypes last time and today. We know what they look like. If the header looks like that, the prototype is the same thing except with a semicolon. Why do you need it? To tell the compiler what it needs, so that you don't have to put the function ahead of where it's being called. You might want to put it in another file. You might want to put it below where the function is called. Make it order independent. So you usually place your prototypes near the top of the program or in a header file. And the program must either use the prototype or have the full function definition before the call. So if I cut mult and paste it up above main, it would have worked just as well. So when you're using prototypes, you can put your function definitions in any order in the source file or in another source file. We played with that. Maybe on Thursday we'll play with it again. Create a second .cpp file and move some of our functions over there. Sending data to a function. That's when you provide those values that get sent in. This is data that we're passing into the mult function. Its technical name is an argument. This is an argument, and the 20 is another argument. And it fills in these parameter variables. So 10 gets shuffled in and copied into X. 20 gets copied into Y. Don't know why I'm tempted to run it. We've already run it several times. Let's go back to here. So the values passed to the function are called arguments. The functions that receive them are the parameters or parameter variables. So in this case, this is the parameter variable. And when the program is invoked, when the function is invoked, it will have to pass something in. Like this. I am passing a 5 to display value. And there, display value, parentheses 5. See, ours is better. It also accepted a title. So this is the argument. Now the argument can be anything that is compatible with this data type, with this parameter type. So it's okay to pass it into it, or it could be some other integer data type, like a short, or an unsigned short, or a character. If it's larger than an int, then you're going to get data rounding, and the compiler is going to warn you about it, like if we passed in a long, and it was expecting an int. Because you can't fit a long in an int, because an int is 4 bytes long, and a long is 8. There's no way it can fit, so it'll just truncate it. It'll try to make it fit, and the results quite often won't be pretty. So if we want to get even more techie wordy, the parameter can be called the formal parameter or the formal argument. The argument can be called an actual parameter or an actual argument. Forget it. Just call the things in the header the parameters, and call the things when you invoke it the arguments, and ignore that slide. Do this. Nah, I guess that's not a good idea. It says that in the book, but unless you see it on a quiz question, you don't need to remember it, and I promise you I'm not going to ask it. So for each function argument, the prototype must include the data type. So we're going to write a function called even or odd that takes an int. Prototype's got to be declared with its parameter type specified there. And then the function header actually has to have a variable name. But it is not a syntax error to put a variable name here as well. And in my opinion, it's a preferred practice, because variable names are useful information. Like if you have a variable named radius, you know an awful lot about what kind of data you're passing to that function. But if it just says int, you don't know what it's expecting.
You did unpause your thing, right?
Yeah, I did. Good. All right. So the value of each argument is copied into the parameter. And we've talked a little bit about that. It's a copy. It's like I hand you a photocopy of the information. I still have the original information. You have the photocopy. So if you try to change it, there's a good chance that I'm not going to notice your change. It's not going to have any effect because I still have the original piece of paper. And the parameter scope is the function which uses it. We've talked about scope before, the lifespan of the variable, like R. R's lifespan is from here to here. If we try to access R from below it in another function, it won't, because it was declared as a local variable inside these angle braces. Now this is also a local variable. It's just a local variable that's defined up here. So is that. That's also a local variable. So the scope of a parameter is the entirety of the function body. If you want more than one function to share a variable, you'll probably have to declare it as a global variable, unless you're creating an object-oriented solution, in which case you can make it a class member. Passing multiple arguments? Yeah, you sure can do that. We've seen it. Add 10, 20, we passed in 2 arguments. The number of arguments in the call must match the prototype and the definition. With that caveat, if you provide default values, then you can just let the function fill them in. So the first parameter is used to initialize the first argument gets copied in, the first parameter, and so on. So when we call show sum, we're going to be copying in value 1, value 2, value 3. Those are arguments. They fill in these parameter variables, num1, num2, num3. And if this code changed the value of num1, if it said num1++, it still does not change the value of value 1, because num1 is just a copy. It's a photocopy, like I mentioned. This is the original document. You can crumple up the photocopy. It doesn't change the original document. Passing data by value. By default, that's what C++ does. It's the only way that Java can pass data around. It's the only way that Python can pass data around. C++ does it by default, but you can convince it to do otherwise. You can convince it to do pass by pointer or pass by reference. And I've demonstrated at least one of those. I don't think I've spent much time on pass by pointers. So changes to the parameter do not affect the value of the argument when it's done pass by value. I would put parentheses pass by copy. That is so important. I may even add it to my notes over here. By default, C++ and every other language uses pass by value, parentheses pass by copy. So the parameter now contains a copy of the argument. Changes to the parameter do not modify the argument. I give you a photocopy of $1, you feel free to burn that photocopy. So passing information to parameters by the value. We've talked enough about this. Using functions in a menu-driven program. Functions can be used to implement user choices from the menu, to implement general purpose tasks. Higher level functions can call, I'm just reading what's on the slide. That always strikes me as stupid. Higher level functions can call general purpose functions, minimizing the total number of functions and speeding program development time. See program 6-10 in the book. Well, I'm not gonna. All right, the return statement ends execution of a function. You can have more than one return statement in a function. But as soon as it finds one, as soon as execution hits one, it returns out of it. So what do I mean by that? What if we had some function that looks like this? It's just going to be a silly function, so I'm not going to give it a good name. Void silly. It takes a parameter x, int x. And the first thing we're going to do is we're going to rule out even numbers. We don't want to do anything with even numbers because we're silly. If x Modulus 2 equals 0. That means it's an even number.
You want us to type this? Even though it's
Oh, I don't care. Do it if you're feeling it. Otherwise, don't. And if it's not even, we're gonna do some stuff to it, right? We're gonna add 1 to it. We're gonna multiply it by 2. We're gonna print it out. And then we're going to return. Now, this doesn't mean it's going to return twice. You can only return once. It's like standing there inside a building saying, get out, right? So if our execution hits this point, get out, it stops, and it does not run the rest of this. So if the number is even, it gets out, and the rest of this code is not run. Your code can have as many return statements as need be, but it can get confusing if you put a lot of return statements in it and it's a long function. A typical programming model is to check error conditions at the beginning of the function. Make sure you have good data. If you don't have good data, return out of it, and then have a whole bunch of code that uses that data. And this kind of models that. It wasn't intentional, but, right? This function is not supposed to do anything with even numbers, so we ruled out the error condition right away so that the rest of this we could trust. I should have made it rule it out if x was equal to 0 and then try to divide by x, something like that. That would have been a little bit more useful. So, typically, a lot of programming books will say that you should only have one return statement at the bottom of the function. But realistically, you're going to see people put return statements in other places in functions. But it's true that if you have a function that's 400 lines long and then there are return statements in this place, that place, and the other place, it's very difficult to understand what it's doing, and it's hard to maintain the code. So, if in a void function, you don't actually have to have the last return statement here. It is assumed. Once it hits the closing curly brace, what else is it going to do? Has to return. But I put it there specifically so that we'd see these two. And if you're programming in Java, the Java compiler will go ahead and highlight that in yellow and give you a warning. Unnecessary return, which is ludicrous. There's nothing wrong with sticking return at the bottom of every function. It's just not necessary if it's declared as void.
Yeah, I was about to say.
Yeah.
Void.
Returning a value from a function. Here's their sum function, but they added, yeah, it looks exactly like our add function. They just called it sum. Double result, the result is equal to num1 plus num2, return the result. The return type has to be compatible with the data that you're trying to return. If I did this, if I just tried to do a return, pretending it's a void, well, it's not a void. It has to return something. Python's a little bit more flexible than that. But Python's a weird beast, a cool beast. I love it. So if you want to, the return statement can be the result of an expression. We did not calculate R and then say return R. We just did the expression right there. But honestly, even a single variable is an expression. It just we don't normally think of a single variable as being an expression. Usually think of an expression as being like multiple variables and plus signs and things like that. So honestly, these two do exactly the same thing. One just stores the result in a temporary variable before returning it, and the other one just performs that calculation and returns it without storing it in a temporary variable. You see what I mean? I think that 90% of this is already familiar to y'all because we've been using this all semester. Wave your hand if you kind of agree with that. I don't see enough hands waving. All right. I'm going to pressure you into waving your hands whether you really agree or not. No, I'm kidding. Okay, so returning a value from a function, the return statement has to match the definition. calling the function should use a return value. Otherwise, why are you returning it? If we have our code here and it says add 10, 20, if we're not storing its result anywhere, then why did we call 10, 20? If it doesn't need to return anything, we should have gone ahead and made it a void to stamp it real loud and clear that we're not going to use any return value from it. Returning a Boolean value. We can return any kind of variable. No reason Boolean variables are different than any other types. You can return a true, you can return a false. How about a function called isEven, which returns a true or a false based on whether it's even or not? Now why don't you write this one down in your code if you feel like typing. Above main, I'm going to write an isEven method, which returns a bool. So bool is even, because I can't even. Alrighty, here we go. Is even, and it's going to take an integer, int x, and we're going to figure out whether x is even or not by doing modulus 2, just like we did in that other sample code. And there's all sorts of ways you can code things. There's always more than one way. So if x modulus 2 equals 0, it's even. Return true. Else, return false. And no, it's not a syntax error that I didn't leave the brace, that I didn't put the braces. You don't have to put a brace if your body of your if statement is only one line of code. Same is true of while and for loops. There's nothing wrong with putting braces around it, and quite often I would, just in case I wanted to come back and expand it. All right. Does anybody recognize how I could replace those 4 lines of code with 1 line of code because you've taken another programming course? Do I need to do if return true, else return false? Well, this generates a Boolean variable right there, right? Because that condition is going to be either true or false. It's either even or not. So in effect, this code is, and don't type this, is saying if true, return true, else return false. All we really have to do is we could have done this. Return x%2 is equal to 0. It does the same thing. It performs that calculation. Is x modulus 2 equal to 0? It's either true or false. Now return it. So this is sort of amateurish. It's not wrong. And for, programming classes, it's fine because it's a lot clearer, isn't it? If you don't recognize what this is doing, then this is blatantly clear. This is a little less clear. With a little bit of experience, though, you ought to be able to recognize that. It performs this calculation. All right, let's write another one called greater than 0, or just maybe greater than. It takes 2 values, x and y, and returns true if x is greater than y. It's going to be another Boolean. Bool greater underscore than. It's going to take 2 values so that it compare them. Int x comma int y. And I'm not going to write this as an if statement. I'm just going to write it in this little shortcut here because I want you to get a little bit familiar with the syntax. Return parentheses x greater than y. And really we ought to be putting a comment about every function we write indicating what its purpose is. So for example, return true if x greater than y, otherwise return false. We should do the same thing for this one. We should go and add a comment that says return true if x is an even integer, else return false. Usually a function will do something more complicated than this, so it's very it's a good idea to have some documentation of what that function is trying to do.
I'm getting a syntax error on return for some reason. It's saying R is undefined, but it underlines the entire word return. I don't know why.
Well, that's interesting. I'll come back and look. All right, I just wanted to make sure that I hadn't caused that by my
Never mind,
bad
it
type.
disappeared. Just went away.
Oh, really? As soon as you compiled it again, it went away. All right, that's cool. So you can return a Boolean variable. You just give it a function that begins with the word bool, and it must contain statements that say return true or false. Well, we've already proven that wrong. You don't have to return true, return false. You do not have to use that language if you return the result of an expression like that generates a true or a false. If that made you uncomfortable, don't type this. You could do bool r is equal to x greater than y, and then return r. Right. That would work just as well, although it's underlined. Oh, because I forgot the semicolon. I'm going to undo those changes. Strictly speaking, these parentheses are not necessary. I just think that it makes it easier to read. That is valid code. Same thing up here. I could have taken these parentheses out. Doesn't mean I can take them out here. It's not Python. We have to have those. But I think it's clearer if we write it that way. All right. We're about to draw to a close. No, we're not. We have a little bit more time. But I said I was going to end early. So let's see where we are. Local and global variables. I mentioned them. Let's go ahead and implement them just so that we have an example of them. We're going to declare a global variable, and one function is going to set it, and the other function is going to print it. So our global variable is going to be called name. String space name. And we're declaring it outside of any function. Don't put it inside main. Don't do anything with that. Now we're going to make a function called set name. It doesn't need to return anything. Void set underscore name. Parentheses in parentheses. But it better accept a parameter. Oh, it doesn't even need to accept a parameter in order to speed up typing. Set name, and we're going to set name equal to Bob. We're going to write another function called print name. Void print underscore name. Parentheses in parentheses. Cout name. Cout arrow arrow quote name is space end quote arrow arrow name arrow arrow MDL. So why are global variables risky? It's because you don't really know what might be manipulating that data. And it kind of requires things to be called in a certain order. If I call print name before I call set name, it's not going to print Bob. Who knows what it's going to print? So we have some rather tight cohesion, meaning that these things have to be called in the precise order which we want in order to get the desired outcome. And if we call them in the wrong order, it's not going to work. And also, what if down here in main, we do name is equal to quote, don't type this. You can if you want, I don't care. Name is equal to Ralph. We forgot that we needed to declare name. Well, we just changed a global value, a global variable right then and there. Without even knowing it, we may not have remembered that we needed to declare that. And so suddenly, name is equal to Ralph, even though we thought we had only set it to Bob. So global variables are not the best idea. I would just say feel a little guilty if you start using them. Let it nag you at night. Not too much, though. You need a good night's sleep. So global variable is one that's defined outside of all the functions, and a local variable is defined in a function. Local variables are hidden from statements inside other functions. Just like my washing machine cannot wash the dishes in your house. Your dishes are local to your house. My washing machine is local to my house. The local variable's lifetime is from when it is created until the closing brace in which it is created. And this will be the last slide. This variable here, product, starts existing at that point and it stops existing there. That's its lifetime. That's its so-called scope. Alrighty.